Two 1 meter long parallel wires are separated by a distance of half a centimeter. The wire on the left is carrying 2 amps of current north, and the wire on the right is carrying 4 amps of current south. So I1 is equal to 2 amps, I2 is equal to 4 amps. The distance between those two wires is half a centimeter, or 0.005 meters, and the length of those wires are both 1 meter. So for part A, determine the magnitude and direction of the force on the left wire. So the force between two parallel wires, or two anti-parallel wires in this case, is mu naught over 2 pi times I1, I2, L over D. Mu naught over 2 pi is 2 times 10 to the negative 7 times, multiply each of the currents, that's 2 times 4 times the length of the wires, which is 1, divided by D, the distance between them, 0.005, and you get a net force of 3.2 times 10 to the negative 4 newtons. And since the wires are carrying currents in opposite directions, that means they're going to repel each other. So the wire on the left is going to move even further to the left. And for part B, how do the magnitude and direction of the force exerted on the right wire compare to the force exerted on the left wire? And it is the same magnitude of force, because the force on either wire depends on both currents, as you can see in the equation, but since the wires repel each other, that wire is going to move to the right, which is the opposite direction. So it has the same force, but the opposite direction, and the justification you can use for that is Newton's third law.